Good morning and a very warm welcome to Automotive Electronics Conference brought to you by Mobility Outlook. I would like to sincerely thank each and every one of you for joining the most coveted conference on automotive electronics at a time when the Indian automotive industry is going through a transformation while managing the crisis of semiconductor shortage. The conference today is being held on the theme Electronics, the Efficiency Augmenter, and is supported by Infineon and MapMyIndia. Since it's a live conference, for a seamless experience, please keep your devices on mute. And if you wish to ask any questions to the speakers, please use the Q&A box at the bottom of your screens. Now, I would like to invite Mr. Dipanshu Sharma, Editor, Mobility Outlook, for his welcome address.
Thank you so much. DT, for the welcome. Greetings, everyone. Automotive electronics has been a subject of discussion at multiple platforms and forums for the past many years, highlighting the importance of the subject in the industry's context. The subject bears more significance today, considering the double whammy that the industry has been dealt with, the COVID-19 pandemic, of course, that brought the world to its knees, and the subsequent blow-up of the shortage of critical semiconductors for vehicle systems. From conventional IC engine vehicles to electric, shared, and autonomous vehicles of the future, the role of electronics is only going to grow. In fact, vehicles are fast transforming into the ultimate electronic devices. It is predicted that automotive electronics will constitute near a third of total cost of the entire car in the coming years. Ladies and gentlemen, with cars becoming software-defined, cloud-connected electronic devices, the demand for automotive electronics will continue to rise in the coming years. High-speed and secure communications and infotainment, high-powered electric vehicles, and autonomous vehicles will continue to drive the demand for power electronics. Looking at the way semiconductors are sourced currently and how the demand for chips continue to grow across other fast-growing industries like personal computers, tablets, gaming devices, smartphones, it is clear that the automotive industry will have to fundamentally overhaul its semiconductor sourcing processes. We will, of course, get far deeper insights into how this sector would develop, the challenges, the trends, the technology innovations, and future opportunities from all our experts speaking in today's conference. In today's conference, we have two technical presentations. The first by Mr. Anup Agarwal from Infineon Technologies, who would speak on the instrument cluster solutions for sophisticated graphics, followed by a presentation by Ms. Rashmi Rao of MathWorks, and she will give us an insight into model-based design for the next generation of software-defined mobility. The technical sessions will be followed by a panel discussion on automotive electronics, chasing opportunities amid a global crisis. The discussion will be held by Mr. Ashim Sharma, partner and group head for auto engineering and logistics at Nomura Research Institute. And as panelists, we have Mr. Dr. Anshuman Avasthi, Vice President eDrive Hybrids and Powertrain at Mercedes-Benz Research and Development, India. Mr. Ramanathan V, Vice President and Head of OE Sales and Marketing at Webco India. Ms. Sapna Ahuja, Chief Operating Officer at MapMyIndia. Mr. P.K. Banerjee, Executive Director at the Society of Indian Automobile Manufacturers. Mr. Srinivas Aravapalli, CEO, Blue Binaries Engineering and Solutions. Dr. Madhusudan Joshi, Deputy General Manager at the International Center of Automotive Technology. For the final session of the day, we are deeply honored to have Dr. N. Saravanan, President and CTO, Ashok Leyland, and Mr. Gaurav Gupta, Chief Commercial Officer, MG Motor India, who will be part of the valedictory session. But before all that, we have our inaugural session, and we're truly honored to have with us Mr. Guruprasad Mudlapur, Chief Technology Officer at Bosch Limited and MD, Bosch Automotive Electronics India, Mr. Binoy Paul, Chief Engineer EE at Mahindra and Mahindra, and Mr. Kaushik Madhavan, Vice President Mobility for South Asia at Frost & Sullivan. But before I proceed with our inaugural session, I would like to thank our partners, Gold Partner Infineon and Technology Partner MapMyIndia, for supporting this event. Ladies and gentlemen, I welcome each one of you to Mobility Outlook's Automotive Electronics Conference 2021. I wish you all a great conference ahead. May I now invite our guest of honor, Mr. Guruprasad Mudlapur, CTO Bosch Limited and MD Bosch Automotive Electronics India, to deliver his keynote address. Mr. Mudlapur, welcome.
Thank you. Thank you for having me on the panel today. It's a real pleasure to do this, especially at a time when auto electronics is on such a high currently, both for the right reasons and wrong reasons. So it's a good time to be in this sector. And let me share my screen, and I will get started with So just let me know when you can see it.
Yeah, slides are visible, Mr. Mudlapur.
Okay, so I will take you through some of the key highlights in terms of market trends, technology, what's causing good growth in auto electronics today, and how do we see this in terms of some of the challenges for the sector in the Indian context. So I'll keep most of the conversation connected to India, but keep referring to trends outside as well. So the slide cannot really start without a quick look at the overall ESDM sector. And give or take different estimates, the Indian ESDM sector has been around 90 billion, out of which the auto electronics sector is about 8 to 10%, depending on how people estimate these things. So it's roughly around 8% or 10% of it. The auto sector has also been having a significant growth over the last few years, and so is the overall Indian ESDM sector, and that's estimated to reach between 300 to 400 billion around 2025. The COVID impact and the slowdowns notwithstanding, I think we should have a steady path towards that sort of a number. And the auto electronics has an exponential growth within this sector. And that's also one of the reasons why we see some of the effects we see today. The overall segment is divided into multiple areas. So a car, you just spoke about it, a car of today or a car of the future has significant electronics content. And I'll talk about that in detail in the subsequent slides. But broadly, we can categorize them as components which get into powertrain, body electronics, braking, safety, ADAS systems, and of course, the large chunk around infotainment and connectivity and such options. So it's a very significant amount of electronics which has come into the vehicle of the future. Starting already with the vehicle of today, and we see these effects in many of the new launches that are coming up now, and we will continue to see this as we progress towards the future. So we've at least within Bosch, we've always tried to map how does a car look in terms of electronics, and what features drive these content. I mean, why does electronics grow in a car, and what is driving it? And there's often a statement that software is eating the world, but I think it's eating the world through, I mean, if software has to eat the world, the teeth and the mouth has to be electronics and semiconductors in some form or the other. So as soon as cars get more complex, as soon as they have more features, as soon as they get lots of additional technologies which are either interconnected or independently managed, electronics plays a key role. And as you can see from the left of the chart, the entry segment car of today, something like 5 lakh Indian rupees kind of a segment, has typically 10 to 12 features which are more or less sort of mandatory, and they're there just because the car has to run. And the overall electronics content in these cars is about 8 to 10%. But as soon as you start to move segments, and these are, by the way, very broad categorization. So there is always a mix and use of features across segment. So a high end of a segment already has some of the features in the other categories shown here. So it's only a representative picture. So the mid segment car of 5 to 12 lakhs has a whole lot of features which are coming in today. And these suddenly boost the number of features which are primarily dependent on electronics to almost 40 to 50 features. And these start to also bring in very high levels of electronics in a car. And the same trend continues. And if we start to look at the high-end cars of today, a premium segment car, the number of features suddenly start to explode. And these are still combustion engine vehicles, not really the electric vehicles of the future. And you suddenly start to see so many features that come in. And many times as either consumers of these cars or as OEMs or as tier ones, we tend to ignore that each of these functions has some electronics behind it, has a whole lot of software behind it. So it's a pretty complex way of putting together a vehicle today. So the more complex the car gets, the more features it gets, the more electronics it starts to get. And if we now try and map this to the electric cars of today or the future, a typical electric car in the Indian context would start around 11 lakhs, 12 lakhs or 15 lakhs, around that kind of a price frame. The number of electronic features in this car is typically already much higher than an entry-level car of the ICE vehicle. It's already a non-legacy behavior here. Lots of things come on board simply because there is a power source which is more amenable to this. There's also more easier introduction of E architectures, and I'll talk about that a little bit later. So a lot of this push much higher levels of features coming into the cars of the EVs of today, even the entry segment. But as we move forward with the EV journey, what we already start to see, I mean, I'm not even mapping the more complex and advanced electric vehicles like the Teslas, but even the more typical ones which would get sold in an Indian environment. We've tried to map what could come into cars like this. And you suddenly see that it's already a very, very high level of electronics. And all this, even without including battery as an electronic component, only considering battery management systems or thermal management systems around battery as electronics and the core battery as a chemical plant in a car. The number of features and the requirements for this suddenly explode dramatically. So this is fundamentally one phenomena that we start to see, which is also aggravating the demand for electronics in auto sector, and the demand for semiconductors which come behind that as we move forward. And closer home, again, two-wheelers are a very hot topic. A typical two-wheeler of today, thanks to legislations around emissions, legislations around braking with introduction of ABS in some segments, comfort features, also lighting moving to LED, already has quite some electronics coming in. But if we move towards a two-wheeler in a few years from now, and I would only say that as a norm in 2025, but some advanced two-wheelers today already have a lot of these features. So lots of these features come in, and each of this has an electronic control unit at the back, or sometimes it's a combination of electronic control units which drive some of these features. So it's a thing which is moving more and more towards high levels of electronics in a two-wheeler as well. But if we map that to an electric two-wheeler in around 2025, where we may see some steady state behavior compared to today, where lots of them are trying out things, and many OEMs have already announced two-wheelers which have most of these features listed in electric two-wheelers of 2025 today. So a lot of these things may come into some models, but will progress into higher levels of electronics, higher levels of features, be it in terms of minimal driver assistance features, or safety features, or things which come into infotainment in a very fancy way. The clusters are becoming very complex in two-wheelers. There is live connectivity to the vehicle, updates to the vehicle coming in all the time. So lots of new features coming in, and the two-wheeler transition towards electromobility pushes the amount of electronics and connectivity, plus of course safety and powertrain related electronics, to a whole new order. I mean, that's a given, and that's where we see large changes happening already now. So if you sort of bracket overall consumption of auto electronics, as I said earlier, we put that into four broad categories: powertrain, brake and chassis, infotainment, connectivity, telematics, and HMI, body electronics, and ADAS and safety. So each of this, we start to now see penetration of these features in a very steady state in the vehicles of today, also into the future. Many discussions we've been having with OEMs in India and global OEMs all point towards a very, very quick transition to this. And mind you, many of these features are coming in with or without legislation driving it. So a lot of times, India has especially had legislation-driven growth in features and technology coming into vehicles. But now what we start to see is cars coming in with level 1 or level 2 or driver assistance, which is not really a legislation-backed thing. So that's something that becomes a driving force in many cars. As affordability goes up, and as the premium segment starts to becoming more and more normal these days, a lot of these features become very, very well sought after in the car. So the future of mobility in that sense holds a huge opportunity for auto electronics. I talked a little bit about EE architecture. I think for us, one of the key drivers of high levels of electronics content, on one hand, has been the aspect of confluence of electric, autonomous, and connected vehicles coming together at the right time, or at the current time. And all of this requires a new look at EE architectures. So traditionally, and so far, majority of the cars or vehicles on road today have been on a distributed EE architectures, where we've had modular or sort of a minimally integrated ECUs, where each function has an ECU. Each function controls some aspect of electronics, and it's more or less an independent way of dealing with things. It's pretty complex. As long as the features are simple, as long as the software can be managed and integrated in a vehicle, these are good ways to deal with it. And the world has dealt with a distributed architecture more or less so far. But what happens when we have a lot of cross-domain challenges coming in, a lot of fusion of features, a lot of domains overlapping each other, we get more towards a domain centralized EE architecture. And this brings in additional complexity in terms of concentration of domains, so domain computers or domain centralized ECU architectures coming in, a lot of cross-domain computing coming in. We ourselves formed a new division within Bosch, which is called XC, which basically stands for cross-domain computing, all to tackle challenges of the architectures coming in at this level, and thereby the complexity in dealing with both hardware and software at this level. But as we move forward towards more vehicle centralized architectures, which are where the more complex cars of the future are looking at, they all move towards vehicle computers and vehicle computers integrated with cloud. So a lot of these kind of architectures come in, which makes the electronics complexity shoot up dramatically. A vehicle computer is more like a desktop computer or even a server grade computer sitting in a car. So you introduced and said the cars of the future are very, very complex. Yes, I think as we move forward, the amount of compute power that comes into a car is so huge that it's becoming a very, very big challenge to manage. So this is another factor which drives very high levels of electronics content coming in. And this is a trend which is very steady. And while we may not see this in all segments in India, while we may see parts of it in different segments, I think the trend towards this is an assured one. More so because electric vehicles are legacy free in many ways as we move forward. And they need to go into this to bring in a sort of good way of handling the electric vehicle topologies, the self-driving car topologies. So L1, L2, L3 levels of automation coming in. And then, of course, a lot of connected features, cybersecurity, and all these coming in. So it's a big requirement that we start to move up into the more vehicle centralized architectures. So sort of summing it up, what are some of the challenges we face in the auto electronics sector today? And as I had one of the large auto electronics operation for Bosch in India, localization. I think a lot has been said about it. Even though we are consumers of such a lot of electronics, we seriously lack semiconductor fabs. We don't have even quality auto grade printed circuit board suppliers in India. And a lot of this puts huge pressure on imports, logistics, managing imports, inventories. So it's a big challenge to deal with here. The overall localization in an ECU remains unfortunately pretty low. It's about 20%, and most of the localized components are mainly the mechanics or the connectors, housings, and these kind of things, and not really truly electronic components, which still get sourced via global supply chains, which are not in India directly. I talked a little bit about the complexity. So the complexity is growing exponentially, and this makes lots of difficult transitions happening in the auto industry as a whole. The manufacturing processes get more complex with electric vehicles coming in. The power levels go up dramatically. Typical cars have inverters which are very high power, battery management systems at very high power. So all these puts a lot of challenges in terms of how we deal with complexity in these cars. So not to talk even about the self-driving cars of the future. just the fact that we get electric cars puts very high levels of complexity in terms of the electronics that comes in. Of course, we have some regional issues to grapple with. We have had free trade agreements with a lot of ASEAN countries. And a lot of these ASEAN countries are also really good at doing a lot of electronics manufacturing. So they have a well-established ecosystem for manufacturing. They have very good logistics hubs. They're very capable of assembling complex parts. So they're also well integrated into the overall manufacturing networks globally. So, and to have free trade agreements with such countries simply means that India can import electronics more or less at the cost of local manufacturing directly from these regions. So that's another challenge that we are dealing with. What's also a missing thing, or maybe not missing, but very minimally handled, is lack of design-led growth. So this has been pretty minimal in my view. As we saw in the e-architecture complexities, all electronics tends to get co-designed with software. So as the software complexity increases, the controller complexity increases, the software hardware co-design requirements become very high. So what we do in India is pretty minimal in terms of hardware software co-design. So designing an ASIC which works very well with the kind of software that we are likely to use. So these are all still very minimal. And the amount of efforts we actually put on electronic design today is also still pretty minimal. Even in big segments like cellular phones, the design-led manufacturing is still very low. It's mostly an application board which has been received from either the semiconductor maker or from China or from somewhere, and that is assembled locally. So this is an area where we need to put quite some focus as we move forward. Last but not the least, I think the quality of engineering talent we have needs to step up dramatically to handle the challenges of the auto electronics design as we go into the future of the automobile. The kind of engineers we get out of college, and unfortunately over the years there has been a dramatic shift towards the software domain. So we don't have that many quality auto electronics engineers or generally electronics engineers coming out. There is a preference for a lot of them to move towards software. And this also puts a lot of pressure on the system to have quality engineers developed, and getting quality electronics engineers is taking quite a lot of time. And this includes different aspects of code design, for example, in terms of PCB layouts, in terms of signal integrities, in terms of EMI, EMC code design. So a lot of these put together becomes very complex in terms of handling this engineering talent. And this is another core area where we need to step up as a country and as the auto electronics industry as well in India. So I would say these are some of the challenges we are grappling with. The opportunities simply are massive, as you saw in the earlier slides. It's really an explosion of opportunities towards the auto electronics growth. And if we can manage some of these sort of high level challenges that we currently have well, I think we can look forward to a very, very good auto electronics future in India. So this is what I wanted to share. Thank you, and open for some feedback or comments.
Thank you, Mr. Mudlapur, for that very insightful presentation on automotive electronics, and also a peep into what is the likely opportunities and challenges for the future. Thank you very much. I will now move on to, if you can stay back, Mr. Mudlapur, we will have some questions from our delegates. We will take the questions together at the end. I would now like to invite Mr. Binoy Paul, Chief Engineer EE at Mahindra & Mahindra, for your keynote, please. Binoy?
Thank you, Dibanshu. Thank you, Mr. Mudlapur, for that interesting introduction to electronics and challenges we have. Glad to be in a session with Dibanshu and team. It's always nice to talk to the industry as a whole. These are good opportunities to interact and understand each other, and share some thoughts as to how we all work together to move forward in the area of electronics. And automotive electronics is definitely talk of the town, as Mr. Mudlapur said, good or bad, but the reality is that we are there, and automotive industry is in a tipping point in terms of importance of electronics, right? So, and glad that Mobility Outlook arranged a session around that. I have few slides I'll take you through and share some thoughts. I did see that a lot of my colleagues and friends and partners are also in the participant list. Glad to represent all of you in what we are, what we're working on and what we will be working on together in the future. So, to start with, an overview of what are the trends, what are the areas which is actually driving this. Again, word, case, and pace, but I think it's still very relevant to talk about that, because that is what is defining how this electronics is becoming more critical to our business in automotive. So if you look at the type of people buying the car, what is the expectation of the consumer? They're looking for a more personalized, more connected, and from an as a trend which we talked about, and more into electric powertrains, and more safer vehicles, and increasingly driver assisted vehicles. Autonomous may be a word which may not feel that we are there, but I would reword it as a driver assist systems, right? And that is here and there already in India, right? And that is driven from a consumer need, which is happening in India. So that there is a consumer need, and then of course there is also a technology which is being developed, which is becoming more and more available to be used in these areas, thanks to the advancement in electronics and software and technologies. So we are in a situation where we are able to develop vehicles with a very interesting mix of market oriented, whatever technologies are necessary for the consumer can be provided in the right total cost of ownership perspective, right? That's always been a challenge, that's always been a dilemma. Yeah, but now is a situation where we are able to do that in India, and that's a great place to be. It's a great place to be able to offer the right technologies at par, or or leading in a global perspective, rather than always being following and figuring out how do we make it happen. So that's why I say this is a very nice time to talk about automotive electronics. Ever optimistic about it. I know there are challenges which you always keep in mind about semiconductor shortages and all that. I think that's a new reality. We have to manage that. Like we talk about COVID as a new reality. Yeah. So manage those situations. But the fundamental fact is that we are able to give more value to our end consumers using electronics. And the trends which are defining it is centralized computing, more of cloud computing, higher expectations on user experience. Like whether you like it or not, all our consumers are looking for more interesting user experiences. Voice-based user interfaces, better graphics. This is driven more from the consumer electronics. An average household or an average individual today has a smartphone, and I've seen many people now don't dial. They only talk to the phone, right? So there's a need for the automotive environment to match to that consumer expectation. So those are key factors which is driving the growth on automotive electronics in my perspective. Of course, there is an underlying advantage of electronics. There is ECU consolidation. There is always a better connectivity, and there is a better availability of cloud compute for us to use. That's all enabling factors to satisfy our the market needs. So some of the main the other aspects about it is the software. Software is eating. I would like to call it software is enabling. Yeah, software is creating more value. Software is augmenting the efficiency of the vehicle. If you look at it from that angle, there's a lot more software platforms available, a lot more open source solutions available. You embrace that. You utilize those solutions for your benefit, and then that creates value. So, for example, Android platform. So infotainment systems, when you develop on top of Android platform, it gives a lot more seamless user experience. It comes with some challenges, but it is now possible to provide a better user experience using the same fundamental solutions which are used in the mobile industry, right? In automotive specific challenges or factors, I would say would be safety and security. One is the angle of user experience, consumer preferences. The other is the underlying unwritten expectations of safety. You have a faster moving vehicle, you have a more better roads, you are driving much more faster, you are feeling more comfortable in the vehicle, you are automatically expected to have a better safety system. You have an advanced vehicle, safety is hygiene. You should have a safer car to drive. Then on top of it, the moment you have higher electronics and higher software, you start worrying about your data security. First is the actual physical security, which is again a given. Beyond that is the issues around cybersecurity, safety related challenges driven by software. The moment you have more software, more electronics, you have to make it, you have to develop in a way that it is more secure and safe. So those are some of those factors which has to be considered in the automotive electronics space. I think in the earlier, this is again everybody's aware of it. I'm sure everybody who's attending this also aware of the domain consolidation which is happening. It is here and now. The age of flat architectures, of modular architectures is gone. Even in entry-level vehicles, all segments of vehicles, we will start seeing domain controllers, architectures, and zonal compute. And ultimately, whether it's a central compute, single central compute is debatable still, but a server-based or service-oriented architecture of software and a software-driven functional divisioning is here and now. The age of one ECU doing one feature and communicating to another ECU, I think that's history. So this is because the cost of ownership, the capabilities of a controllers are exponentially improving. We are talking in terms of 30, 40, 50 kilo DMIPS of compute inside a controller, inside a car, and that's just one of them, right? So we are sitting on an opportunity where we have a lot of compute power available, which means we can actually define much more configurable vehicles, scalable configurations by software. That improves, that creates a lot of efficiencies in the way you define a vehicle, the way you package a vehicle. So this is actually, this is where I actually, when the Bangshu told me about the name, the accelerator part of it, I think this is where the real acceleration of vehicle design and automotive electronics is happening, where the way we are able to make things modular in a software way rather than in a hardware way. I think that's the key advantage we are getting into when we get into domain architectures. Just a comparison, I can't have a presentation to all of you without touching upon our latest vehicle and architecture. So just a quick comparison of what we did in Mahindra between the XUV500 to XUV700 from an electronics architecture perspective. So the number of course, the number of issues have gone up even though we have gone into a multi-domain architecture. That is purely because thanks to the amount of features that increase. The new architecture in 700 is still a domain and modular mix. It's a journey we are getting into. But the key thing we need to notice is the number of networks, the number of interfacing, the number of messaging between ECUs is also gone high. And that is what is driving the need for domain controllers and domain architectures. This is just an example of one domain controller which we have, which is the cockpit domain controller. Just as an example, a Qualcomm based system where we are having 3 domains and two operating systems, hypervised and another operating system, physical. So this is a good example of the way things are progressing, of how a multiple so there's if you look at it, the infotainment is on an Android system and the cluster is on an QNX system. That that gives you a feel of how differentiated a single domain controller can be from an end user point of view. QNX being more secure, Android being a bit more open, and then you bring in your cloud connectivity, and then it's a seamless operation, but the underlying architecture ensures that the domain separation is managed with the software architecture. So the power of domain controllers, hypervising, and software architecturing is very, very high in the new automotive electronics world. Just a thought about what lies in the future. This is something which we are all going to work together and develop. But today we are talking more till now I talked about more of in-vehicle. Now we have to think beyond that, the vehicle to cloud. We are in 4G, we are going to be in 5G very soon. What are the additional use cases? What more can we do with cloud? Cloud opens up a lot more opportunities in a vehicle environment. Now, of course, we have to take care of online and offline and all that scenarios, use cases. But the moment you are online, what more can you do with utilizing the compute power which we are getting in cloud? So that is a big area of opportunity. We are, in my view, as an industry in India, we are just getting started there. As a huge space where we all will see a lot of activities. The other very, very interesting thing is about vehicle to vehicle. It is, I don't know, again, Dr. Mudlapur, Mr. Mudlapur mentioned about, are we waiting for we are regulation driven or some usage, consumer need driven. I think the vehicle to vehicle has to go from a consumer usage driven. And there is, again, once you have a 5G solution plus any way of communicating between the vehicle, the V2V portion, there are very interesting opportunities around that area. And I think this will define a lot more of value we will be providing as automotive community to the automotive consumers. Of course, the need for better maps, HD maps with lot more integration and value additions around that is a given to get this happening. But the advantage there is the cloud part of it is getting sorted thanks to our adjacent industries. Yeah, we don't have to drive that in a way. So we can ride on that wave of the cloud solutioning. So I think this I've just captured a few bullet points. What is happening? We are getting into software-defined vehicle. Why is that happening? The electronic content, again, open sourcing, standard electronics designs, automotive quality components getting more and more available. I'm talking in terms of global perspective here. We do have a challenge of localization and all in that area, but the solution is available from a technology point of view. Those solutions are available and affordable. The other thing which I didn't mention, which is again a big elephant in the room, if I can say that, is artificial intelligence. And computer vision is one of the basic solution, value out of it, but there are a lot more possible with AI, and AI plus cloud plus all the very high quality sensors which we are able to get into the vehicle. We are in a cusp of talking about virtual sensors in the vehicle, with the right algorithms. Electric drive systems, of course, brings in a lot more need for electronics computing. I think that's an oft-repeated and oft-discussed topic. That is power electronics also come into play when it gets into electric drive systems. So one of the things we share is today in the vehicle, E&D architecture is the nervous system, but when it becomes electric vehicle, it becomes the cardiovascular system also. So that brings in that much more complexity or expectations out of the automotive electronics community to make it happen. Right? The other interesting aspect I would touch upon is the real-time embedded software. Now we keep talking about the high-end UI, UX, cloud, AI, everything, but the fundamental system software, the embedded software, what is possible today with again better compute and faster compute, is that you can actually manage vehicle dynamics using a lot more software. Yeah, the braking systems, the vehicle dynamic system. There is also domain control architectures around vehicle dynamics, which makes the ride quality, the vehicle control, the vehicle dynamics much more user friendly, configurable. Tuning becomes much more easier. There's a lot less mechanical and physical things to be modified. You can do a lot with the software tuning, right? So that's another big value addition which we see. It's a very unsung part of the electronics. Okay, there's a lot of development which has gone into that, where vehicle dynamics, braking systems, the vehicle architecture itself, can be done in a way where we actually tune it with the software which runs inside. That is a paradigm shift in the way vehicles are developed and designed today. I think, and then software definitely driving a lot more differentiation. I'll just quickly put a thought on everybody's mind about how in automotive the software should be developed, or how it is happening globally, or what is the trend. So typically what we see, this is from an OEM perspective, from my perspective, like there is a thought about, okay, we'll get some software work done by software houses. That is the bottom right corner. That is where we typically an OEM starts. It's more of a tactical decision making there. Then the next level of maturity from a software ownership is start using standardized off-the-shelf components. The OEM start telling, okay, you have to use this stack in all the ECUs to the tier one, so that I get a unified interfacing and architecture, right? Typically in the areas of network, CAN protocols and all that. Then you get into a more of a software-centric development, where we start getting into creating more value propositions, differentiating solutions using software, right? Where you'll end up with tying up with software IP creators, startups, and you try to differentiate your product from a software perspective. Then the holy grail of it is actually owning the software, and software becomes a core business of the vehicle. The software becomes a core of the vehicle. It's powertrain and vehicle powertrain, and those are the differentiation factors in the vogue today. But there is a scenario where your software capability, your software value you bring to the table becomes more the business drivers, So oft repeated example is Tesla, right? So if there is a product differentiation you can create by the capability of software. Now that's where the automotive electronics becomes the very, very, very embedded into the product. Like you cannot ignore it anymore. That is what is defining the vehicle. So that's the power of this domain, the automotive electronics and automotive software. It goes hand in hand. There is no way you can differentiate these things, and the value you bring to the vehicle development and vehicle the journey ahead. And as a parting comment, I would say I keep hearing there is a lot of hesitation that are we ready in India? I think we are more than ready. Okay, I'm ever optimist in this space. The capabilities, there is a lot of engineering, a lot of software, automotive work getting done in India for the global organizations, right? So why we cannot do it? It is definitely doable. It is happening, and I see a bright future in automotive electronics. Yes, there are challenges, semiconductor challenges, localization challenges, lack of ecosystem. Yes, they're all there, but we can do it in a much more, the typical Indian word of frugality. It's doable. Is the message I want to part with. Thank you.
Thanks so much, Binoy. Thanks so much for that insightful presentation and talk on, the core message that you're giving us today is that electronics and software will go hand in hand, and there is a lot that software will do. One other interesting message or point that you made was with electric vehicles, EE systems are going to become a cardiovascular systems, and moving on from being their nervous systems of vehicles today. Thanks very much, Binoy. We will take some questions later. And at this stage, I would like to invite Kaushik Madhavan, Vice President Mobility, South Asia at Frost & Sullivan. Kaushik, over to you.
Thank you very much, Deepanshu, for that. It's wonderful to be here. Thank you very much for inviting me once again. This topic couldn't have been better. Just at the right time. And I couldn't have started it better when Guruprasad first said that the automotive electronics is on a high. I mean, in multiple ways, right? I mean, that's probably the best way to capture it, where we are, how this industry is evolving and how we see some of the growth opportunities. So let me, share a few perspectives of Frost & Sullivan in terms of where we see the opportunities in the automotive electronics space. I'll try to be brief, in the interest of time. Quite a few points, have already been mentioned by Guruprasad and Binoy. I'll try to cover some of the areas that haven't been talked about so that we can complete the picture. If I can share my screen. Sorry, Binoy, if I can request you to unshare your screen.
Oh, sure, yeah. Is it removed now?
You have to say stop share. You have to click that button to stop sharing.
It says, okay, yeah. It was giving me only a pause share. Okay.
Yeah. Okay. No worries. Now I can. Not a problem. Thanks a lot, Binoy. I appreciate it.
Sorry for that.
So perfect. Deepanshu, can you please confirm that my screen is visible?
Yes, Kaushik, we can see you.
Perfect. So now let's look at some of the areas where we see opportunities for growth. This is something Guruprasad already mentioned in his opening talk. We do expect, very similar to the numbers mentioned by Guruprasad earlier, that by 2030, maybe about 50 to 55% of the overall cost in passenger cars is going to come from electronics. Now, the interesting part is, according to some estimates, obviously there are different estimates out there with different, let's say, slightly varying numbers. But the bottom line is, the automotive electronics market globally is set to account for about $480 to $500 billion by 2030, right? You will see different numbers in different sources, just a few variations here and there. But as a thumb rule, we are looking at a $500 billion market by 2030, right? Now, obviously, that is driven by a lot of sensors, ECUs, electronic control systems that are coming into the vehicles that we have already seen in Guruprasad's presentation. But I want to look at it in a slightly different way, putting it all together. So, how do we see this $500 billion market split by 2030? Let's look at the value chain layer. Electronics, when you say electronics is going to account for 2/3 of that $500 billion market, well over 2/3 of that $500 billion market by 2030. Semiconductors for another 90 billion, and software for about, let's say, 90 to $100 billion. Now, when we say electronics, we are talking about all your harnesses, sensors, controllers, and so on and so forth. So clearly, the electronics part of it is going to be the most significant contributor or driver when we talk about the value chain by 2030, well over $300 billion, right? The next layer is the focus area layer. Here we are talking about different vehicle as applications. If you had seen this particular pie, let's say about 10 or 15 years ago, powertrain would have accounted for a huge majority, close to about 2/3. But the share of powertrain is decreasing as we go forward. The share of connectivity and infotainment is increasing. The share of chassis and safety, primarily driven by ADAS technologies, is increasing. So by 2030, we expect infotainment connectivity to be the most significant contributing focus area layer, with about, let's say, $150 to $160 billion, followed by powertrain at about $130, $140 billion, and chassis and safety. Now here, it's a combination of advanced driver assistance technologies as well, right? Today, if you look at chassis and safety, it accounts for about 13 to 15%, and by 2030 likely to account for about 24 to 25%. That's almost a 2x growth in the next 10 years. I think this is something Guruprasad also mentioned in one of his slides in terms of how safety and advanced driver assistance technologies, obviously in collaboration with connectivity services, infotainment, will be the biggest contributors, over the next 10 years. So needless to say, comfort is also going to be a significant driver, but comfort technologies, or the growth in comfort technologies, are primarily driven by customer pull rather than regulation, right? Now, the third layer is the geographical layer, right? Here we expect APAC to be the biggest contributor, close to about $200 billion, followed by North America at about $140 billion and Europe at about $120 billion. So this is primarily at the manufacturing level, right? That means when I say APAC is going to account for about $200 billion, this is based on the consumption at the vehicle manufacturing level. How much of electronics is going into the vehicle, depending on the number of players, number of OEMs who are present in these regions. So very clearly, you can see that the growth in automotive electronics, although is going to be very, very significant, from 2020, which was just about $230 or $240 billion, almost 2 to 2.2x in the next 10 years. So to about $500 billion by 2030. So this is how we see the split in terms of how the overall electronics pie is going to be shaped up. Now, some of the mega trends driving growth in electronics, very clearly, this is something, Guruprasad and Binoy both mentioned. On the one hand, you've got the regulatory compliance that is driving the increase in electronics because of, let's say, either because of fuel economy regulations, emission regulations, crash safety regulations, so on and so forth. And on the other end, you've got your customer pull, forces driving, all your connectivity, infotainment systems within the car. So in between, we also have different regulations emerging for, let's say, accident avoidance or mitigation systems. So we will see these driving forces, to be, primarily shaping up the automotive electronics market as we go forward. Now, as a result of that, some of the issues that get addressed, right? I spoke about, the regulatory compliance, driving, emissions, economy, congestion, and on the other hand, when we talk about looking at driver distraction, driver fatigue, warning, error fixes. How do we eliminate the element of driver distraction when we talk about increased electronics coming into the vehicle as we move towards, let's say, level 1, level 2, level 2.5 autonomous vehicles. I just got a message saying my internet connection is a little unstable. I'll stop my video. I'll come on the video again at the end of my presentation. Sorry about that, just to ensure there is continuity in at least my audio. Then we are looking at system solutions. Obviously we've got electrification on the one hand, then you've got ADAS and driver assistance systems. Then you've got V2X, right? Autonomous driving and V2X, V2I, V2V, and V2P, vehicle to pedestrian communication as well. Then you've got the final layer of auto systems, right? Which will form the basis, behind all the electronics technologies, right? All your powertrain, electrification, the value layer I showed in the previous slide, talking about powertrain, chassis, body, comfort, convenience, infotainment. So this is how we see the mega trends driving, the growth in electronics as we go forward. To talk about India, what is needed today is the establishment of a circular value chain, right? Today we have, capabilities in manufacturing in bits and pieces, right? Usage, very, very significant. Sourcing, again, in bits and pieces, but end of life is a big question mark today in India, right? How do we complete this value chain by enabling and investing in different elements, right? From sourcing, design element as well when it comes to manufacturing. This is an area, where we need a lot of investment and improvement. A point Guruprasad also mentioned, how can we improve our capability and competency in the design element, right? So we need to establish a very, very comprehensive, there's a need to establish a comprehensive circular value chain in India that looks like the entire value chain, right from conceptualization to manufacturing to usage and to end of life and recycling as well. Now, in order to do that, we envisage 4 pillars, right? What could be the framework for an automotive electronics manufacturing ecosystem, right? On the one hand, let's look at the first pillar, all about business viability. How can we have government support in establishing a viable, ecosystem, whether it is incentives or subsidies on parks dedicated to electronics manufacturing. We already have a few of them in India. We need more of them. The second pillar is about shared responsibility, right? A shared stakeholder ecosystem or a shared responsibility framework. So it is not just the OEM or the component manufacturer or the tier 1 supplier who is going to be involved. We need to bring in non-automotive stakeholders as well, right? Associations, nodal agencies, monitoring agencies who will play a role in the overall manufacturing ecosystem. Which brings me to the third pillar, right? How can this nodal agency be empowered to facilitate the circular value chain I spoke about earlier? Not only from the point of manufacturing and sourcing, but also from use, reuse, recycling, and second life application. So the fourth pillar is all about encouraging investments. Again, Binoy also touched upon that. How can we have an inclusive ecosystem where we obviously from the Atmanirbhar Bharat or the Make in India perspective, how can we encourage investments in India right from the academic level? A very important point which Guruprasad made is the engineers that are coming out of the universities today, how equipped are they, how competent are they in order to be used in the manufacturing ecosystem, automotive electronics manufacturing ecosystem, considering the evolution of technologies that we are going to see over the next 10 years. Now, some of the key competencies that are required today in electronics manufacturing, you've obviously PCB manufacturing, surface mount technology, for automated production lines, Electrostatic discharge precautions, how can we look at some of the ESD precautions in handling electronic components in circuit testing and PLC. So these are, let's say, 4 or 5 key competencies required today in electronics manufacturing, and how can we integrate this into the academia, right? How do we encourage more academia industry collaboration in order to bring these capabilities at the grassroots level, right? So that the engineers who come out are competent enough and are qualified enough to be able to contribute in a meaningful manner. Now, short-term growth opportunities, we just wanted to highlight what could be some of the technologies that will offer short-term and medium-term growth opportunities, obviously driven by compliance. We are talking about ABS, ESP, or even airbags, which will offer huge growth opportunities in terms of revenue generation, primarily driven by regulatory compliance, right? So all your short-term growth opportunities will be driven by compliance and regulatory compliance. Now, when we talk about medium-term growth opportunities, here we are looking at a combination of regulatory compliance and infotainment connectivity services as well. All your telematics enabled services and equipment are going to be driven by both regulatory compliance and also the need for improving TCO, especially when we talk about fleet operators, both passenger car fleet operators and commercial vehicle fleet operators. The bottom line for them is reduction in downtime, improvement in efficiency. So TCO becomes a very, very important factor. And again, electronics and telematics will play a big role in helping many of these fleet operators improve their TCO. Now, complexity, right? Guruprasad spoke about how the technologies are evolving in India and how complex they are becoming. So we thought, okay, how can we classify or bucket some of the technologies in terms of complexity and how much revenue they can generate over the years? Now, if you look at some of the low complexity technologies, or typically your rear parking assist, right? All your ultrasonic rear parking systems that can be bought in the aftermarket as well, although most of these are becoming OE standard equipment. Aftermarket has also driven this to a great extent. So fairly low complexity technologies that can be leveraged in order to gain, some market share and revenue generation by the suppliers as well, smaller suppliers as well. Then you've got the medium complexity technologies, all your BMS, TPMS or SCR for selective catalyst reduction, some of the standalone technologies, that are both driven by regulatory compliance and by customer pool. So these can be targeted by mid-level suppliers if they are going to look at, enhancing their automotive electronics capability and their contribution in the market. Then you've got the third layer, which is the high complexity technologies, all your airbag electronics or ABS electronics, which are safety critical. Any technology that is going to be safety critical, right, is going to be classified as a high complexity technologies, because obviously they need to communicate with multiple subsystems within the vehicle in order to become more and more effective. So we can look at different sets of technologies. So for an Indian component manufacturer or for an Indian supplier, you need to pick and choose where you want to play, right? Whether you want to play in the low complexity, medium complexity ecosystem, where you can develop your own capabilities and expertise and be a standalone player, or if you want to look at the high complexity technologies where you will need collaboration with one of the global majors in order to understand, in order to have a technology transfer or a knowledge transfer, and then equip yourself to become a key player. Now, this is just a case study. I'm going to skip this slide. So last slide, if we have to look at the value proposition that India can bring in the global automotive electronics ecosystem, there are three pillars. The first one Oops, sorry about that. The first one is about end-to-end system development, right? Today, we already have system capability and integration capability. Binoy showed that very, very beautifully when he spoke about how we can bring embedded firmware, software, hardware design and development all together. So clearly, this is one pillar where India has a big role to play in terms of end-to-end system development. The second pillar is about multiple domain expertise. Not only are we looking at our traditional powertrain expertise in terms of diesel engine development, petrol engine or gasoline engine development, alternate fuels, we are also looking at multiple domains in terms of infotainment, connectivity, right? Chassis and ADAS, driver assistance system. So ADAS in fact has become a very interesting topic in India, where quite a few of the smaller, let's say tier 2, tier 3 component manufacturers are becoming interested in. So that seems to be, one of the high growth areas where we do see, simple, ADAS components and subsystems playing a big role in elevating the Indian component manufacturer community to the global standard. So multiple domain expertise is definitely the second pillar where India can add significant value. The third, last but not the least, is affordable and value engineering. Again, touched upon by both these speakers earlier. How can we integrate design capabilities, design and development capabilities, collaborative, development. So I think this is where India, with its significant expertise in value engineering or affordable engineering, is going to contribute in a big way. So I think these three pillars put together definitely can put India on the global map as a powerhouse in terms of automotive electronics, and how we can add value to the global automotive industry, not only from the perspective of manufacturing, but also from the perspective of new business models as we move towards shared mobility, personalized mobility, last mile connectivity, last mile delivery systems, and so on and so forth. So the future is very bright for India, and I'm pretty confident, that going forward, the capability also of some of the tier 2, tier 3 component manufacturers in India will be elevated, and they're going to play a big role going forward. So with that, I'm going to stop. Back to you, Deepanshu. Thank you once again for this opportunity.
Thanks so much, Kaushik, for that wonderful presentation, giving us great insights into where are opportunities lying for Indian suppliers going up to 2030. And I also truly appreciate your slide on establishing a circular value chain. I'm sure our participants today have had a great insight into what electronics has in store in the future. Gentlemen, we will have a couple of questions. I'll head straight into the Q&A. One question is for you, Mr. Mudlapur. If you can, Mr. Mudlapur, if you can kindly switch on your camera. Okay, so there is this question from Amit T. Amit wants to know, what is the next technology to PCB that you would see to overcome productivity and technology challenges?
PCB, is it?
Yeah.
Okay, so I think it's not necessarily next technology, but the way things have evolved, PCB has been the mainstay, and of course there are different forms of printed circuit boards where we assemble components. But outside of that, there is assembly on ceramics, so for especially higher powers. And one step back, there is also technology like SIP, which is system in package, where semiconductor assemblies happen together, even with multiple processes. So there can be a controller at 45 nanometer, there can be a power chip at 180 nanometer, and both of them sit together on one substrate, and they are bonded into one package. So system on chip is a very common thing, which again, of course, that could still reside on a PCB, but there is very high levels of integration happening. So I would say these are the typical trends that are available already. And this is used today as we speak in multiple topics.
Thank you. Thank you, Mr. Mudlapur. I'll have a question for Kaushik. So what are the technology you see as a future for ESD? Kaushik? Okay, Kaushik, can you hear me? There's a question for you. All right, I'll come to Kaushik later. Binoy, this is not for any specific, any of our specific, experts today, but I'll take this to you. Do you see semiconductor manufacturing going to happen soon in India, considering most parts are imported from Taiwan and China? So there's this anonymous attendee who has asked this question.
Okay. So it needs an anonymous answer, I guess. So I guess, see, as I said earlier also, I guess we will be riding on a wave of advances in consumer electronics, right? The demand for semiconductor is much higher in India from a consumer electronics and mobile handset and all that. So if at all a semiconductor manufacturing will happen in India, it will be driven more from that industry to start with. And then the automotive qualified will follow. Now, that's my view of it. It's a very investment intensive activity, right? And then, as we have seen, when the semiconductor shortage is happening, there's so much more, just not the fab. There is a lot of ancillary systems to be in place to ensure that that fab runs seamlessly. And once you start, there's a challenge. There's so much more to be thought through when that happens. So it's an ecosystem development rather than just a one-off investment. So it will happen because the demand is there, the market is there. But when it will happen, I believe it will more driven by the demands from the consumer sector.
Right. Thank you, gentlemen. Thank you so much. I'll end this session here. We've moved slightly beyond time. So thank you once again for being part of our inaugural session. Mr. Mudlapur, truly appreciate your time. Binoy,
thank you.
Thank you so much for addressing our session today. And Kaushik, thank you once again. Gentlemen,
thank you. All the best for the
Thank you all. Thank you.
Thank you.